Hello, this is Al, K0CN, and in this video I'd like to show you the fold-over kit for the Heights tower system used along with the NN4ZZ Tilt Plate. Here we see the tower, an 84-foot crank-up tower weighing about 750 pounds tilted over horizontal to the ground. The tilt-over kit consists of a 4-foot stand, a Dayton geared motor, and a 6-foot-long Acme screw, a threaded rod, which runs through a bushing at the base, and a threaded nut at the top, which is mounted to the rear leg of the tower. At the top we see a step-IR DB18 antenna, which weighs approximately 110 pounds. Here we see the NN4ZZ Tilt Plate. The beauty of the tilt plate is that it allows the antenna to rotate and the elements remain relatively horizontal to the ground whether the tower is vertical or horizontal. With the tilt plate, the boom of the antenna can be brought down to about 4 feet off the ground. Without the tilt plate, the boom of the antenna would be some 20 feet in the air when the element tips touch the ground. This shot shows the antenna from just a little further out, with the tips of the elements just touching the grass. Now let's take a look at the process for moving the antenna back from its horizontal to a vertical position. This is done by switching the motor on so that it rotates in a clockwise direction. As we mentioned earlier, the Acme screw rotates through a bushing which is anchored to the top of the 4-foot stand. The Acme screw is also rotating through a threaded nut which is fixed to the rear leg of the tower. As the Acme screw draws the rear leg of the tower downward, the tower will rotate back to its vertical position. As you can see here, the rotation of the screw is quite slow, and the process for going from horizontal to vertical or vertical to horizontal is about 10 or 11 minutes. This is a nice rate of speed, and it allows you to take care of any tangles or other issues that might arise during the process of raising or lowering the tower. Here towards the end, I've sped up the video a little bit to cut back on time. As the mast approaches a more vertical position, you'll see the Carl lock, that aluminum hook that's hanging down from the tilt plate, come into position underneath a U-bolt, a stirrup that you see on the right-hand side. This is the apparatus that's used to lock the beam into place when it's in its vertical orientation. My experience has been that it's quite effective. Now we've reached the point where the tower is nearly vertical. Our job now is to stop the motor when the holes align. When we reach that point, we put a pin through the holes and lock the tower into position. And here we have one last look at the tilt plate now that the tower is locked into a vertical position. We've had it for about a year now and are very happy with it. That's it. That's a look at the fold-over process for the Heights tower and a look at the NN4ZZ Tilt Plate as used with my step-IR antenna. Thanks for watching.